Hi, I'm coming to you today with the next notes. Actually, these come before the transversal notes, but I just kind of found them in a notebook today from last year. And this will help you on the volume of spheres, cylinders, and cones. Again, I already posted the notes. I'm just kind of vocalizing what they are, what they mean. Again, this is from last year. So on these notes, it says, what do cylinders, cones, and spheres have in common? So that was our essential question. And I just break it down. How do I find the volume of a cylinder? Well, a cylinder is like a can of soup, right? And so what we learned before is when we find volume, we find the area of the base. In this case, the base is a circle. So how do I find the area of a circle? Pi times radius again, and then we multiply it by the height. So basically, it's area of a circle times the height. Turn it down, please. Okay. Addison, can you go help turn our light on, please? Sorry. So when we put it all together, the formula for a cylinder is pi times the radius squared. Remember, that's not times 2. That's radius times times the height. So here's an example. This cylinder has a radius of 4 and a height of 12. So I'm going to plug it in. Pi times 4 squared times 12. Addison? Kinsley, turn it down, please. Okay, bye. Sorry. I can't help it. When you have little kids, they always interrupt. Okay, so once I input this information, we're not going to use the pi button unless it tells us to use the pi button on our calculator. We're going to use the value 3.14. Okay, so when I put in 3.14, all right, we are going to get, let me just get my calculator here. So when I input 3.14 and I multiply it by 16, right? I'm multiplying it by 16 because 4 times 4, right? 4 times 4 is 16. And I'm going to multiply it again by 12. Okay? And I get 602.88 feet cubed. Okay. Now, many of you guys might notice this answer down below. What that means is sometimes you're asked to find the answer in terms of pi. In terms of pi means we're not going to put a value in for pi. We're going to leave pi like a variable. Okay, so basically all we did to find 192 is we took 16, we got 16 by 4 times 4 times 12, and that gives us 192. And then we just tag pi on right behind it. And we always have feet cubed because it's volume. Okay, the next one is a diameter of 10 and a height of 6. Well, remember, the formula doesn't call for the diameter squared, it's the radius squared. So we're going to have to divide that by 2. Yeah. So we're going to take 10 divided by 2, which is 5. Okay. So we're going to have pi times 5 squared. Again, that's not 5 times 2. That means 5 times 5 times 6, which is the height. So when I multiply it out, 3.14 times 25 times 6, I get 471 inches cubed. Now, if I wanted to put it in terms of pi, it doesn't have the answer here, but in terms of pi, I would just take 5 times 5, which is 25, times 6, which is 150. It would be 150 pi inches cubed if I were to leave it in terms of pi. Okay, so I'm going to skip a little bit. I think you guys kind of get this, right? So now it talks about how do I find the volume of a cone? All right, so how do we find this? We take the area of the base. What is the base again? It's a circle. We're going to times it by the height, just like we did up here in the volume of a cylinder. Sorry, my phone is Needs to be turned off. So we're going to find it times the height. But this particular time, a cone, and I wish I had this to show you, every cylinder fits exactly 3 cones. So if you think about the pyramid and the rectangular prism, a pyramid, or not a pyramid, a triangular prism and a rectangular prism, a rectangular prism fits exactly 2 triangular prisms inside of it. Well, a cone and a cylinder have a similar relationship, except instead of it fitting 2 cones in a cylinder, it actually fits 3. So you'll notice here, to find the volume of this cone, you will take the area of the base, which is the circle, times the height, which that gives you the cylinder. Now we have to divide it by 3. Now, I must have liked fractions last year, but dividing it by 3 is a lot easier than trying to put 1/3 in a calculator if you have a calculator like mine on my phone, unless you turn it sideways and, that kind of stuff. But so here we go. It says 1/3. Here's my base. What's my base? My circle. And here's the height. So let's practice. Here's the example. My radius is 4. My height is 8. So I'm going to take pi, which is 3.14, and I'm going to multiply it by 4 squared. So if I get pi, 3.14 times 16 times 8, I got 401.92. But that's if it was a cylinder. This is a cone, so now I have to divide that number by 3. And I get 133.97333333 repeating. In this case, unless it otherwise specifies, we're going to round it to the nearest hundredths. That's this place right here. So because it had a 3 after it, it means the 7 is going to stay the same. Okay. Page 2. So now it says, what is the formula for the volume of a sphere? So I tried to draw a cylinder, right? Do you guys see that there's a cylinder in there? And the sphere touches the top, it touches the bottom, but then there's like this little bit of space around the edges and up around the bottom. Okay. Well, a sphere is 2/3 of a cylinder. So it takes 2 cones to make a sphere. It's kind of an interesting thing. Okay, right? Because a cone is 1/3 of a cylinder. So here the formula is 2/3 times pi r squared times height. Okay, or hopefully you're tracking with me. So if we continue here, you'll see that if I have 2/3 pi r squared height, that I can start to finagle it and understand why it becomes 4/3 pi r cubed, because it's really kind of tricky actually. So here's pi r squared times the diameter, right? That's what we've been talking about. Well, you could technically use 2/3 pi r squared d, but there's another way we can do it. We could say that d is the same as 2 times the radius, right? Isn't 2 radii the same as the diameter? So if we were to use 2r, what you would see here, if you can see this next line here, is then we would have 2/3 times pi times radius squared. Shh. Addison, please. Times radius squared times 2 times r. Okay? This is how we derive the formula, by the way. So you'll notice that this r doesn't have an exponent. There is one, though. It's imaginary. It's this 1. So remember the rule of exponents says that if I have exponents with the same base, I can add them. So 2 plus 1 is 3, which is where this little number 3 comes from. Okay? Then I can take the 2, the coefficient 2, and multiply it by 2/3. So it shows you down here what happens when you multiply those 2 together. you get 2 times 2, which is 4. 1 times 3 is 3. So what's left is pi. The r's came down to, or simplified to, r cubed. So the actual formula for a volume is 4/3 pi r cubed. And that streamlines it so that there's only one variable here. If you look at this one up here, we had 2. We had r squared and d. Okay? R squared and d. So this is just another way to write the formula. This is the long version. This is the simplified. Excuse me. So we have a sphere. It says find the volume. So it might be an interesting way to look at this where we have 4/3 as a fraction, but in this example, we have 4 at the top next to all these numbers and then 3 at the bottom. Well, that's the same as 4/3. It's just that they're separated, right? The numerator stayed on the numerator side and the denominator went down below. So if we go, Addison, turn it down. So if we go 4 times pi, 3.14. Okay, so okay, 4 times 3.14 times the radius, right? If this whole thing is a diameter, then the radius is half of that. So that's 3.5. And then it's got to be cubed. So 3.5 cubed means 3.5 times 3.5 times 3.5. And I actually get 538.51. But what we haven't done yet is we haven't divided it by 3. Because we have to divide it by 3 as the last step. So divide 3, and we get 179.503. And the 3 repeats. So the 3 will tell the 0 to stay the same. So you could write 5-0 here or just 5. Okay. So then I assigned some homework last year. It says to find the volume if the radius with a radius of 3.1 meters. Find the volume. I'm wondering what this was the volume of. Oh, I think that, excuse me. I'm trying to see here. This is a cylinder. This must be of a cone. This must be of a sphere. Maybe not. Let me see. Let me check it. So if I had 4 times 3.14 times 1, 3, and divided it by 3. Oh, it's a sphere. So 1 is a sphere, 2 is a sphere, 3 is a sphere. It must have been that we probably didn't finish this in one day. And then number 4 was to write the steps you would use to find a formula for the volume of a figure. So how would I do that? There's a bunch of different scribble here. So don't worry about number 4, but these are the notes basically walking you through what each one means. It might be handy to write them down on paper or print them out and have them next to you while you do the Alex assignment on volume for Math 8. If you have any questions, hit me up. All right, bye guys.